Okay, last section. Tonight we are talking about functions, section 1.7. And functions are very important, so important that almost every single unit we will always talk about functions. So we'll talk about a different aspect each time. It's a very large topic. Even tonight's lesson won't be complete. We'll have to do some of this in class tomorrow. But we'll go ahead and get you started tonight. So what is a function? Okay, function is a rule that establishes a relationship between two sets of data. So I want you to think of a function as a relationship. Okay, it's a relationship between two data sets. One data set is called the input and one data set is called the output. And this is a really good graphic. It helps me understand sort of how a function operates. I like to think of it as a machine. Okay, and that machine has an input. So here we see this number 3 would be considered the input, and it's being plugged inside the function. Okay, and this is sort of like the function rule right here. This is what happens to the input numbers. They kind of get manipulated by these operations. So in this case, the operations are 2 times the number plus 5. And once you do that, once you say 2 times 3 is 6 and plus 5, you get the output. And this output happens to be 11. So for every input, there is a unique output generated. Okay, and that's what a function is. Down below here, we see function notation. Okay, don't get thrown off by this. This says f of x equals 2x plus 5. And I don't want you to think of this as multiplication. It's not f times x. Think of that f as standing for a function. Okay, and that x is a value. Okay, so really what this means is the value of the function at x. We just went over an example where we asked, okay, what was the value of the function at 3? Okay, so that number kind of tells you what your input number is going to be. Well, the value of the function at 3, when we plugged in the 3, we said 2 times 3 plus 5, we got 11. Okay, so we call this the input and this guy the output. Okay. All right, so how do we recognize functions? Okay, well, we have to pay attention to this one very, very, very important rule. Okay, and it says up here at the top, in order to be a function, each input can only have one output. That is super important, because you might forget that at some point. Okay, but each input can only have one output. Those are pretty ugly looking stars right there, I guess. All right, let's take a look at something that is a function and something that's not a function. Okay, here for the top guy, this guy is a function. And here's the test. We look at each individual input. So take a look at the 0. Okay, what does 0 spit out as an output? Well, 0 spits out a 5. Does 0 ever spit anything else out? And the answer is no. It looks like 0 only spits out a 5. That means we're still preserving our functionhood. Take a look at the 1. 1 is an input. When I plug in a 1, okay, it spits out a 7. Does 1 ever spit out anything other than 7? Doesn't look like it. Okay, so far so good. Even over here, this 1 also spits out a 7. Okay, so 1 only spits out a 7, and it does that so in 2 separate cases. Here we have a 3, and the 3 spits out a 32. The 3 never spits out any other number. So it looks like we have a function there. Okay, down at the bottom, we have something that's not a function. Go ahead and see if you can identify why the relationship at the bottom is not a function. All right, which number is kind of screwing it up? Okay, it's not the 0. The 0 is good to go. 0 spits out a 5. It only spits out a 5. Over here, the 2 spits out a 25. It only spits out a 25. But the culprit, so to speak, is the 1. Sometimes the 1 spits out the 6, and then sometimes the 1 spits out an 8. So here we have 2 different outputs for one input. That can happen, and it's not bad. We're not making a judgment call. It's just not a function. Okay, not a function. Okay, to be a function, each input can only have one output. And what we're seeing right down here is one input having two different outputs. So whenever that occurs, we do not have a function. Okay, hopefully you have your pencil and paper ready. We'll move into examples here in a second. Before, let's talk about domain and range. Okay, when we talk about functions, okay, we want to know this terminology, and hopefully you saw some of it in middle school. Domain is the collection of all of the input values. I think of it as sort of like where the function lives on the graph. Okay, what are the x values that have a graph associated with it? The range is the collection of all the output values. Okay, and that's going to be associated sort of with our y values. So domain is kind of like our x values, and range is kind of like our y values. So let me give you a quick function right here. Let's say here we have our input, and here we have our output. Now you don't need to copy this one down, okay, but we will have some that you need to copy down in a second. Just so you know, our input values are associated with our x values. So x is typically our input, and our output values, you guys might have used x and y last year in your t-charts, but for functions, instead of using y, we use f of x, the value of the function at the value of the function at x. So x is the input, f of x is the output. Okay, take a look at this guy. Let's say my input values are 3, 4, 5, and 6. And the output values in this case, let's just say you plug in a 3 and it spits out a 7. Let's say you plug in a 4 and it spits out a 9. And let's say you plug in a 5 and it spits out an 11. And you plug in a 6, it spits out a 13. Okay. Is this a function? Yes, it is a function. The 3 only spits out a 7, the 4 only spits out a 9, the 5 only spits out an 11, and the 6 only spits out a 13. Okay. Let's go ahead and determine what the domain and range are. And this is very simple. This will be on your test, by the way. The domain, remember, is just the collection of all of the input values. So you really just have to look over at the input side of your chart. So the domain of this function would be 3, 4, 5, and 6. Okay, and the domain is always associated with the x. The range is the collection of the output values. Okay, so what's the range for this function? Well, that's simple. It's the output value. So the range happens to be a 7, a 9, an 11, and a 13. And if any of these values are to double up, you don't necessarily need to write them down twice. Writing them once would be good enough. So domain, collection of the input, range, collection of the output. Pretty simple stuff. Okay, make sure you have that pencil and paper ready. Let's hop into examples. Remember, anytime you see the blue stuff, the blue examples, you're going to have to turn this in to me. Okay, so I'm going to ask you if you think certain things are functions. And remember, to be a function, you have to abide by that one rule. For each input, there is one and only one output. And I do want you to draw these with me. So I'll expect you to have these t-charts drawn. Okay, so for number 1, let's go ahead and draw a nice little input-output table. And we're going to label it input. And output. And remember that our input is associated with the x value, and the output is associated with the f of x value. We're going to go over this in class tomorrow, and I'll expect you to know what I'm talking about there. Okay, so what I'm going to do is I'm going to give you your inputs, I'm going to give you your outputs, and then underneath your function table down here, maybe go ahead and write a blank where you're going to put your answer. And you're going to answer the question, is it a function? So yes, it is a function, or no, it is not a function. Okay, here are your inputs. Go ahead and copy these down along with me. 3, 7, 8, 9, and negative 4. That's your domain. And your output, your range, let's have 6, 5, 6, 2, and 1. Okay, so I want you to think about this. Don't wait for me to answer. Maybe hit pause, consider the table, and then go ahead and write down your answer. Yes, it is a function, or no, it is not a function. All right, what did you come up with? Well, believe it or not, and this might have tricked some of you guys, the answer is yes. Okay, this is indeed a function. And this is where you're really going to have some logic skills here, because some of you guys might be saying, well, wait a second, there are 2 6s there. How can that be a function? Remember, the rule is each input has one and only one output. And you have to consider the inputs individually. Okay? So let's start with the 3. What does the 3 spit out? Well, the 3 spits out a 6. Does the 3 ever spit out anything else? And the answer is no. So if this input only spits out one output, the 3 only spits out the 6, so far we have a function. The 7 spits out a 5. Does the 7 ever spit out anything else? No, it just spits out a 5. So far we have a function. The 8 input spits out the 6 as its output. The 8 never spits out anything else. Our function hood is maintained. The 9 only spits out a 2. The 9 never spits out anything else. And the negative 4 only spits out a 1. It never spits out anything else. That's why this is a function. Each input has only one output. So you'll see here that it's possible that you could have similar outputs, or the exact same outputs, that really has no bearing on whether or not something is a function. Okay? And if that's still confusing, remember, each input has one and only one output. Let's try another one for number 2. You'll need to draw this table as well. So another input-output table. Go ahead and label this input and output. And just remember the input is associated with the x value and output is associated with the f of x value, which is kind of like the y. All right, here are your inputs and outputs. Once again, I want you to answer this before I go over it, so go ahead and leave yourself a blank down at the bottom. For your inputs, let's use these. 2, 0, 1, negative 3, 2, and a 5. And here are the associated outputs. 5, 6, negative 2, 10, 1, and 8. Okay, and maybe if you need time to think about this, you can go ahead and hit pause and come up with your answer before I write mine down. All right, so the question is it a function, yes or no? Okay, the answer here is no. Okay, this is not a function. All right, can you tell me why it's not a function? In other words, who's the culprit here? Who's kind of messing it up? And it is the number 2. Okay, here we have 2. The 2 spits out a 5. Does the 2 ever spit out anything else? And yes, it does. This 2 also spits out a 1. It looks like the input 2 sometimes spits out a 5 and sometimes spits out a 1. And that's not a one-to-one correlation. Okay, to be a function, each input can only have one output. Here we have an input 2 that happens to have 2 different outputs. Okay, and that's why it is not a function. Okay, hopefully you're getting a better idea of how to identify these things. Let's go ahead and continue with a couple more examples to do on your own. Okay, so this is example 2. You'll need to copy these down. And I will go ahead and write them both at the same time. You do need to copy them. And then we'll go over a quick explanation of whether or not they are functions. So same question, is it a function? Okay, and I'll give you some input-output values. You should be copying along with me on your paper. And remember, you want to write your answer here at the bottom. So that's something for you to think about there on number 3. Number 4. Sometimes these T-charts are labeled differently, so sometimes you'll hear people use X and Y. Sometimes you'll see people use input, output. It's always a little bit different. Sometimes you'll see them use X and f of X. Okay, and here are the associated output values. So go ahead, you have these copied down now. Go ahead and you can figure these out on your own, right? Either yes, it is a function, or no, it is not a function. And make sure you have a reason for your answer, okay? Because obviously both of these are kind of designed to trick you a little bit. All right, let's take a look at number 3, and if you're not done, pause it, and then when you're ready to go, unpause. Number 3, function, yes or no. Okay, hopefully you got this now. You can think your way through it. Number 3 is yes. Okay, this guy is a function. Why is he a function? Well, the reason will always be the same. Oops. Each input has one and only one output. The 3 spits out a -2, it never spits out another number. The 4 spits out a -2, never spits out another number. 5 spits out a -2, never spits out another number. All of these have one output. Each input has only one output. Okay, so that's why that guy is a function. All right, by that same rationale, is number 4 a function? And that answer has to be no. Okay, not a function. Well, why is this guy not a function? Well, each input has more than one output. For example, the 3. All right, 3 is really the only input here, but one input in this case happens to have multiple outputs. Sometimes it spits out a 5, sometimes it spits out an 8, sometimes it spits out a -1, sometimes it spits out a 0, sometimes it spits out a 10. So one input happens to have 5 different outputs. That's possible. It's just not a function. Okay? So that's the reasoning you'll have to use, and you will have some of these on your test, and I'll try to trick you, so make sure you really understand that definition. All right, congratulations, you've finished your first unit. There will always be a little page here at the end just to kind of remind you these were the major topics. And this was a very easy unit. I'm expecting A's from all of you guys on your first test. Make sure you do study though. You'll want to go back through all these notes, your examples, your DMR notes, and those examples as well. And these are briefly, very briefly, the major topics. We talked about variables, the difference between expression and equation, what the word evaluate means, how to evaluate expressions, exponents, the order of operations, when do we evaluate radicals and absolute value signs, where do those fall in the order of operations, equations and inequalities, and also the algebraic translations. How do we take something and write it into mathematical language, and vice versa? How do we take something in mathematical language, write it into English? Briefly went over expectations for tables and graphs, and then functions is a big one. Okay, so congratulations. You'll finish your assignment. We'll do a little bit of a review, and then you will have your first test here pretty soon. All right, signing off. Good job.